Today our topic is polynomial. So, any algebraic expression is in the form like a1 x to the power n plus a2 x to the power n minus 1 plus a3 x to the power n minus 2 plus dot dot up to a n is a polynomial, and here is the x is only variable, so we can say this is an one variable polynomial. And the most important point, that n must be whole numbers, that is 0, 1, 2, 3, 4 and so on. So the two mandatory condition for any algebraic expression to be a polynomial is algebraic expression should be in this format and power of the variable should be the whole numbers. Let's take an example. 3x square minus 5x plus 2. See, there is power 2, 1 and 0, and it is a one variable function, one variable. Now if we take another example, 4x square minus 5xy plus 3y square. Now this is another example. See here, 2, power of x and y is 1, so we can say this is also an polynomial, but it is two variable. Okay. Now all the polynomials, so before we proceed, let's take another example. X plus 1 by x. Is this a polynomial? No. Why? See, if we modify 1 by x, we can write x to the power minus 1. Okay. Now see, we already told that power of each term should be whole numbers. So minus 1 is not an whole number. So we can say this is not a polynomial. Okay. Now next. X square minus root 3x plus 2. Is this a polynomial? Yes, because the power of each term, see, here is 2, here is 1 and here is 0. We don't need to see this. We always watch carefully the power of the variable, not the constant. Okay. So here this is a polynomial. Okay. Now now see, there is power of x 2, and we can write like this, x to the power half. So this is a whole number, but half is not a whole number. According to our definition, power of each term should be whole numbers. so this is not a polynomial. Okay, so next up, next stage. Now we can rename all the polynomials like this. See, uh, sorry. See, here the variable is only x, so we can rename this polynomial like this: f of x. Okay, we can rename it like any g of x, h of x. Take any alphabet f, g, h, but in bracket we should write the variables. Okay, like see, y square minus 7y plus 3. This is a polynomial of variable y, so we can rename it as g of y. Okay, now see, this is a polynomial of two variables, so we can write g of x comma y. Understood the renaming portion? Okay, so next move to the next topic. Our next topic is degree of a polynomial. Next topic, degree of a polynomial. Now, what is degree of a polynomial? Highest power of variable in a polynomial for one variable polynomial. Let's understand this with an example. See, we write hx 5 x to the power 5 minus 4 x cube plus 3 x square minus 3. You see, this is an one variable polynomial. So according to our definition, what? Highest power of variable in a polynomial. So highest power of variable what? 5. Highest power of variable what? 5. So degree we can write 5. Okay. Now For multivariable polynomial, for multivariable polynomial, sum highest sum of powers of the variable. Let's understood this with example. See, f of x comma y comma z, like this, 3 x cube y minus 4 x z plus 3 x y z. Now see, this is a 3 variable function. So for multivariable polynomial, highest sum of powers of the variable. Now let's sum of the powers. 3 plus 1, 4. It is 1 plus 1, 2. It is 1 plus 1 plus 1, 3. So the highest sum 4. So the degree is 4. Understood? Okay. So next, move to the next topic. And one thing, write a note. Constant polynomial, example 2, 3, 4. Any constant term are called constant polynomial, okay, and zero polynomial is 0, okay. So always remember that any constant term we can say a constant polynomial and 0 as 0 polynomial. Now degree of any constant polynomial is 1. Degree of any constant polynomial is 1, and degree of 0 polynomial is undefined. These are two most important concepts. Remember that. Degree of any constant polynomial is 1 and degree of 0 polynomial is undefined. Okay. Now next topic, coefficient. What is coefficient? Let's look at the definition. Numbers associated with each term are called coefficient of that term. Let's simplify with some examples. See, if x equal to 3x cube minus 5x square plus 7x minus 1. Okay. Now let's see, 3 is associated with the term x3. So 3 coefficient of x3. Okay. Now here minus 5 is associated with x square. So minus 5 coefficient of x square, and this coefficient of x, and always remember that the constant term, any constant term is the coefficient of x to the power 0. Always remember that any constant term is the coefficient of x to the power 0. Okay. And any missing term, coefficient of missing term is 0. Always remember that constant term is the coefficient of x to the power 0 or y to the power 0 or z to the power 0, and any missing term, coefficient of any missing term is 0. Say if I asked you what are the coefficient of x to the power 4 in, what are the coefficient of x to the power 4 in this polynomial, you will say there is no term like x to the power 4. So we can say coefficient of x to the power 4 is 0. Understood? Okay. So next move to the next topic. Our next topic is zeros of a polynomial. Zeros of a polynomial. Now what is zeros of a polynomial? Simply, if we take fx equal to 0, wait, x equal to, if x equal to a, for which f of a equal to 0, then we called x equal to a is the zero of a polynomial. Okay. Now see, let's take an example. See, fx equal to x square minus 5x plus 6. Okay. Now let's find out some others value, f of 0. So how we can find out f of 0? See, we put x equal to 0 in the right side. We put x equal to 0 in the right side. So that will become 0 square minus 5 into 0 plus 6. That is 6. Okay. Now let's find out f of 1. So we put x equal to 1 in right side. 1 square minus 5 into 1 plus 6 equal to 1. Equal to 1. No, sorry. Equal to 6 plus 1, 7, minus 5, 2. If we put minus 1, f of minus 1, So minus 1 square, 5 into minus 1 plus 6, 6 plus 1 7, 7 plus 5 12. If we put f of 2, that is 2 square minus 5 into 2 plus 6, this will become 0. If we see f of 3, that is 3 square minus 5 into 3 plus 6, this is also 0. Now see, these two values, becomes 0. So we can say at x equal to 2 and x equal to 3, for x equal to 2 and x equal to 3, fx will become 0. So we can say x equal to 2 and x equal to 3 are zeros of fx. Okay, understood? Now, if in exam, examiner told you to find out zeros of a polynomial, see, they ask you an fx like x square minus 20x plus 96. So they ask you what are the zeros of the polynomial. So if we try to find out the zeros like this, that we start from 0 and continue, so this will be a longer process. So what should we do? We should put fx equal to 0. Put fx equal to 0 and then solve this expression, and solve the expression with middle term factors. You will get x minus 12 into x minus 8 equal to 0. So from here we can say either x minus 12 equal to 0 or x minus 8 equal to 0, that is x equal to 12 or x equal to 8. Understood? So in this method we directly find out what are the zeros of a polynomial. Okay. Now see, if you are given, if the sums like this, fx equal to 3x plus 2, and they are asking about what are the zeros of the polynomial, just put fx equal to 0 and find out the value of x. See, minus 2 3x minus 2 by 3. So x equal to minus 2 by 3 is the zeros of that polynomial. I think all are clear up to that. Okay, so move on to next topic. Next, the most important concept, that is remainder theorem. Now what is remainder theorem? If we divide fx with x minus a, if we divide fx with x minus a, then remainder will be f of a. This is our theorem. The theorem is stating if we divide fx with x minus a, then remainder will be f of a. Let's simplify with some examples. See, fx equal to, you say x cube plus 3x square minus 5x minus 6. Now examiner asks you to find out what will be the remainder of this, what will be the remainder if fx is divided by 3x minus 1. Okay, first find out zeros of first find zeros of the divisor. Here this is our divisor, so let's find out its 0. 3x minus 1 equal to 0, that means x equal to 1 by 3. So here x equal to 1/3, put it in this polynomial. Okay, put it. So x equal to 1 by 3, that means 1 by 3 whole cube plus 3 1 by 3 square minus 5 by 3 minus 6. You will get 1 by 27 plus 1 by 9, sorry, 1 by 3 minus 5 by 3 minus 6. We will get 27 1 27 6 120 plus 42 162 5 close to 7 16 plus 3 19 minus 197 by 20. So this is our remainder. Okay, so in this method we are getting the remainder without actually division. Okay, this is the process. Now the next concept, that is factor theorem. It is similar like the remainder theorem. If x minus a is a factor of fx, then if x minus a is a factor of fx, then f of a equal to 0. Let's simplify this with an example. Let fx equal to x square minus 20x minus 96, and they are asking check whether x minus whether x plus 4 is a factor. Whether x plus 4 is a factor. First step is similar. Find zeros of that. This x plus 4 equal to 0, that means x equal to minus 4. Put it in the fx, f of minus 4. So minus 4 square minus 20 into minus 4 minus 96, that is 16 minus plus 80 minus 96, so 0. See, it satisfies the condition, so we can say x plus 4 is a factor. So these are the basic concepts of polynomial. I think I explained all the topic to you. Thank you.